Welcome to the show. Today, we need to talk about the incredible Xenobots and how they are suddenly trending because of headlines like tiny living Pac-Man robots have learned how to reproduce. Well, it's misinformation. They don't reproduce, they replicate. I actually mentioned these living robots in a previous video, but it was just a quick mention. So today, let's go deeper. They are living robots, made up of frog cells in a lab and designed by a computer. So we get all of these interesting shapes. They use small bits of skin stem cells from frog embryos with cellular extensions called cilia to act like little motors, if you will. They have fewer cell types than a skin biopsy and no sex organs, brains, or nervous systems, which is important to know. They contain only enough nutrition to allow them to complete a few basic tasks. Once these Xenobots were able to run around in the lab dishes, the researchers found that they could gather up loose frog cells that then come together to form a new Xenobot. Well, that's weird, but also unexpected. So they are indeed creating more of themselves, but they are not reproducing in the traditional sense by any means. This entire situation is so new that they had to come up with a new name for it: kinematic self-replication. These bots are not splitting cells as found in nature. Here, the bots are collecting loose parts and assembling other bots. Imagine a room full of robot parts and other robots come to collect them. Then they build new robots using these parts. It's like a function built into the software. By default, if the Xenobot was in a spheroid shape, it could only manage one new generation of bots before dying out. After some new optimal shapes were generated, the bots could then replicate themselves for 4 generations. That shape? C shape. That's why the headline from earlier called the Xenobots Pac-Man. As they roamed around in the lab dish, they could collect frog cells in this new shape and create new Xenobots after reaching 4,000 to 6,000 cells. The fact they can replicate themselves means the future use of Xenobots has grown substantially. But what exactly do they plan to use them for anyway? Well, biomedical applications is a big one. While it might creep a lot of people out, this is kind of the first step to nanobots we always see in the movies. They could be used to sculpt tissue, deliver therapeutics, or even better, remove cancer from our bodies. They already want to use them in our oceans to remove microplastics. They could also be used to find and remove radioactive waste. I do worry a little that the researchers never could have predicted any of this and that they are constantly being surprised by these complex systems that they created. They do say that this is actually a safe way to explore science, so I guess, like always, trust the science. If you're still unsure about these little brainless creatures, you're not alone. According to Dr. Douglas Blackiston, there are 2 main ethical concerns surrounding the creation of Xenobots: danger to humans or the environment, and the potential welfare of the Xenobots themselves. For the first, scientists are unable to do any testing outside the laboratory or clinical studies without a variety of institutional, state, and federal approvals. Our current work is proof of principle only. For the second, any animal research is subject to institutional and federal oversight. And we also consult with ethicists when designing our studies. While these are made from frog cells and they were created by humans and then they change their abilities to replicate themselves, is this going to be like Jurassic Park, where the
scientists were so preoccupied with whether or not they could, they didn't stop to think if they should?
As always, thanks for watching, and did you learn today?